capacity analysis, we have gone through what does it mean. We are doing it on uninterrupted flow facilities. We talked about these equations for capacity and free flow speed. Okay, the adjustment factors for speed and capacity. We did this example. Okay, we did the example. We didn't do the example. We do the example. We didn't finish the example, right? We just looked at the equations and the factors, right? So let us start with the examples for free flow speed. In these two examples, there are two examples, okay? These two highways. So you have to calculate the free flow speed, okay? Both of them. One is for freeway, the other one for multi-lane highway. Okay, for freeway, we have a 6-lane freeway, okay, and 12 feet lane and so on and so forth. So for the freeway, this is the equation. So I need a factor for lane width, I need a factor for lateral clearance, and I need total ram density. I need three things here, okay. Factor for lane width I can pick from this table if I know the lane width. So if I go here, the lane width is 12 feet. For 12 feet, the factor is 0. So I'm doing the first one, freeway. Factor for lane width 0. Then factor for lateral clearance. Lateral clearance, right side, I only need right side for the freeway. It's 4 feet. 6-lane freeway, 3 lanes in each direction. 6-lane freeway, 3 lanes in each direction. So 3 here, okay, and the lateral clearance was, I forgot, 4 feet. 4 feet. Okay, 3 lanes, 4 feet. So factor is 0.8. Then I need the ram density. Ram density given 4. There is no factor, you just put the ram density itself. Okay, how much is that? Okay, so pretty easy. Moving on to multi-lane highway. For multi-lane highway, we are following this equation. So I need base free flow speed, lane width factor, lateral clearance factor, median factor, access point factor. Okay. So first of all, I look for base free flow speed. Base free flow speed is given here 65. Okay. Then I need the factor for lane width. Lane width is 11 feet. 11 feet, the factor is 1.9. Then if you need the factor for lateral clearance, now for multi-lane highway, lateral clearance is total, right plus left. Now right side lateral clearance is given as 2 feet. Okay, left side is not given, but it is given as undivided. So I told you in the last lecture, if and I told you the reason as well, if you remember, if it is undivided, then we took the left hand side as 6 feet. Okay, so 2 plus 6 will be 8. It's a 4-lane multi-lane highway. So I come here, 4-lane, okay, and 8 feet. How 8? 2 for the right hand side. For the left hand side, I'm adding 6 because it is given undivided. Okay, so 8 feet, 4-lane, factor is 0.9. Anybody has any confusion about this? Is this clear? Okay. Then moving on, I need the factor for median type. Variant type undivided, factor 1.6. Then if you need the factor for access point density, access points per mile. I have 20 access points per mile. Come here, factor is 5. If I give you 22, you can do interpolation. If I do give you 22 access points per mile, you can do interpolation here. Okay, but now 20 access points per mile, I will take 5. How much is that? Okay, so there are no questions. Then I can move to the next stage. Once you find out the free flow speed. Now remember, I told you you can use equations to find out the free flow speed, or you can do it directly in the field using the spot speed analysis. Okay. In your case, for the projects, you have the spot speed study. Once you did that, the study or the equation, you will move on to the next stage, and the next stage will be one of these three. Either you are doing operational analysis, or service flow rate and service volume analysis, or design analysis. Operational analysis means you are finding out level of service. Operational analysis means there is a highway segment and find out the level of service. This is operational. Service flow rate and service volume analysis means that you are finding out these two factors. Okay. To remind you, what do we mean by service flow rate and service volume? The maximum flow rate of the level of service is called service flow rate, and the maximum volume of the level of service is called service volume. Okay, so to find out these two things for any level of service is called service flow rate and service volume analysis. Okay, and then we have the design analysis. In the design analysis, you have a future highway and you want to find out its number of lanes for the future level of service. Okay, so you want to find out the future number of lanes for the future level of service. This is design analysis. Okay, so operational analysis, find out level of service. Service flow rate, service volume, find out these two things. Design analysis, find out number of lanes. Okay, now which one of these are you doing for your term projects? What is required from you? Find out service volume, service flow rate, find out level of service, or find out the number of lanes. Which one is required from you in the end? In the end, like after you finish your project, what are you supposed to find out? Level of service, service flow rate, or the number of lanes? Tell me. Yeah, anyone. What are you doing in your term project? Which of these three you are doing in your term project? Yeah, you are finding out level of service. Okay, so you are doing operational analysis, but you are also doing the second one, because you will make the speed flow curve as well and do the diagonal lines. So you are doing both. You're doing the first one, the second one, both. Okay, so just a clarification. So this is the equation for finding out flow rate, and this is used in operational analysis. Vp is flow rate. If you remember, we have used it in the free flow speed equation earlier. V is the volume from the field, 1 hour volume. Okay, PHF is peak hour factor, you know. N is number of lanes in one direction. N is in one direction. That means volume is also in one direction. Okay, and you will do it for both your directions separately. Direction 1, direction 2, you will do them separately. Okay, don't combine volumes, don't combine number of lanes. Okay, both of these things are for each direction separately. And then you have the factor for heavy vehicles, FHV. Okay, peak hour factor you already know, number of lanes you already know, volume you already know. BP I've used earlier. The only new thing here is FHV, factor for heavy vehicles. Okay, and we will discuss it later on today, inshallah. If you are doing service flow rate and service volume analysis, then this is the equation which, or these are two equations which you can use. The first equation gives you service flow rate for level of service I. Okay, service flow rate for level of service I. So I refers to the level of service. Now, can somebody tell me the levels of service we have? What levels of service we have? What are the possible values of I? Tell me. What are the possible values of I here? Tell me. Yeah, what levels of service we have? You forgot E, huh? You are in a hurry. Or because E is not in your grades, that's why, huh? You don't get E grade. So, but yes, apart from E, you are correct. Level of service can be A, B, C, D, and E and F. But service flow rate is not for F. F means traffic jam. So SF can be for A, B, C, D, and E. You cannot have a SF and SV value for F because F refers to traffic jam. Then flow and volume does not make any sense to us. Okay. So SF means service flow rate for level of service I. MSF means maximum service flow rate for the same level of service. Maximum. So SF is service flow rate and MSF is maximum service flow rate. N and FHV I already told you. Okay. Then you have service volume for the same level of service. You multiply SF with peak hour factor. Okay. So the only thing which I want to explain here further is MSF. So we have service flow rate and we have maximum service flow rate. The difference between them is this one, MSF is under ideal conditions. SF is under real conditions. Okay. So MSF is under ideal conditions and SF is under real conditions. That's the difference between these two. Yeah. And if you multiply SF with peak hour factor, you get volume. You multiply any flow rate with peak hour factor, you get volume. Okay. So this is general. Then if you are doing design analysis, you will be required to find out number of lanes, and the number of lanes comes from this equation. Okay, so here we are using DDHV. Okay, what is DDHV? You have exam next class. DDHV can be there. What do we mean by DDHV? What is the meaning of DDHV? DDHV is AADT. Yeah, directional design hourly volume, yes. Okay, AADT is daily, DDHV is hourly, so they are not the same. Okay, so congratulations, you know about it. Okay, now in all these equations, you have seen the factor for heavy vehicle. So whatever type of analysis you are doing, you need to calculate FHV. FHV is calculated using this equation. In this equation, you see two factors. PHV, which is percentage of heavy vehicles, and FHV, which is, sorry, EHV, which is the equivalency factor for heavy vehicles. Okay, PHV is how much percentage of heavy vehicles you have, and EHV is the equivalency factor for those heavy vehicles. Percentage, you know, heavy vehicles means all trucks and buses are considered as heavy vehicles. Okay. And trucks and buses, they have more than 4 tires. So any vehicle which has more than 4 tires can be considered as heavy vehicles. uh, so you calculate their percentage from the traffic. EHV is compared to a car, what is the effect of one heavy vehicle on traffic, that is EHV. Okay, in comparison to a car, what is the uh, impact of a heavy vehicle on the traffic on the road. Okay, so that is called EHV. So because heavy vehicles are they are bigger and they are slower, so having one truck in the traffic is not as having one car. Okay, having a truck has more effect than a car. So how much more is that effect? That is called as EHV. Okay. Now heavy vehicles can be divided into two categories. Earlier they were divided into three categories: buses, trucks, and recreation vehicles. But now they are just dividing into categories according to their bodies. We have SUT, single unit trucks, and we have TTs, which is trailer trucks. So heavy vehicles are divided into two categories: single unit trucks, trailer trucks. Single unit trucks are single body vehicles. Okay, so you have a truck which is single body. Trailer truck means there is a truck and behind the truck you have the trailer. You must have seen them, the trucks which carry cars. Okay, they are trailer trucks. Okay, and there are other like this as well. So there is another unit attached to the truck, and obviously it has more tires then, because that extra unit also needs more tires. Okay, so single unit trucks is a smaller one but still a truck with single body, less tires. And trailer trucks is a bigger one with bigger body and extra units attached and more tires. Okay, usually single unit trucks are more in traffic and trailer trucks are less. So there is a type of heavy vehicles, and the other thing is there is a type of the terrain as well. So terrain also has an effect on the EHV factor. Okay, so a truck which is going on a steep slope has more effect than a truck going on a level surface. Truck can move faster on a level surface, but on the steep slope it will go even slower compared to the speed of the truck on level surface. So EHV needs to change according to the terrain, because the movement of heavy vehicle also changes according to terrain. So terrain conditions can be of, let me show you this one. Terrain conditions are mainly two types, and then within one type we have two subtypes as well. So total three, two main, and then within one main you have two subtypes. So total three. Two main types are extended grade and general terrain. Extended grade and general terrain. Then within general terrain we have two subtypes: level and rolling. Okay, what are the conditions for these terrains? They are written in this flowchart. Okay, so if your gradient is more than 3% and length is more than 0.25 miles, you have extended grade. Gradient less than 3%, length more than 0.5 miles, extended grade. Gradient more than 3%, length less than 0.25 miles, rolling. Gradient more than 3%, length less than 0.5 miles. You may have rolling if the gradient is less than 2%. So less than 3% can be 3.5, oh sorry, 2.5. Then 2.5 will not be level, it will be rolling. Okay, so let me give you one example. Let's say you have gradient 4% and length 2 miles. What type of terrain we have? Extended grade, level, or rolling? Which one do we have? Yes, extended grade, yes. Okay, so this is how you decide. Now let's say, so you can find out the terrain from here. Now going back to the point of EHV. So we find the terrain, and then if you have the first type, you can get the EHV from this table, a small table, you just get it from here. Either it is 2 or 3, okay, if you are on this side, on the right hand side. If you are on the left hand side, then your life becomes more interesting, and there are other examples as well, okay. So you can have the, you can practice on them about the terrain, okay. So I was talking about if you have this one, the extended grade condition, okay, like I gave you 4% gradient, and the length was how much? 2 miles. So you have extended grade, okay. Now if you have extended grade, then you will ask me which type of heavy vehicle is more, or are they equal? Do I have single unit trucks more, which is most of the cases? Do I have them equal, or is trailer trucks more? Okay, so you have to identify terrain condition. Then you, if you are on the extended grade side, so there is no effect of type of heavy vehicle here, either it is 2 or 3. But if it is extended grade, then you have to consider the distribution of the heavy vehicles within their types. So for example, if you have extended grade, the one which I gave you, 4% and 2 miles length, then you will ask me, okay, are single unit trucks more or less? I tell you trailer trucks are more, okay. Then you will look into this table, okay. If I told you that both of them are equal, then you will look into this table for EHV. If I told you single unit trucks are more, then you will look into this table, okay. So the selection of the table for extended grade depends upon the distribution of heavy vehicles. So if, for example, if I have 4% gradient and 2 mile length, and I have more trailer trucks, now I come here, look into this table, 4% is between them, you have to do interpolation, okay. You will see the percentage of total percentage of trucks. This is total, okay, this is total, and this is 30/70 from this total, okay. So I have 6% trucks, for example. So from the total traffic, 6% are trucks. In these 6%, 30% are single unit and 70% are trailer trucks, okay. So these percentages are from this total, okay. So for example, if the gradient was 4.5%, the length was 2 miles, okay. You will take the last number, because I have only up to 1 mile. After 1 mile, the last number will be taken. So whenever you reach the extreme value here, you cannot do interpolation for the next one, okay, because I don't have for 1 and then 1.5. If I have 1 and 1.5, I can do interpolation. It's not there. I will take the last number, okay. 6% trucks, 4.5% gradient, 2 mile length, I will take this one, okay. The EHV will be 4.6, okay, and so on and so forth. If I told you I have both of them equal, so 6% trucks, 4.5% gradient, and 2 miles still here, so my factor will be 4.37. Let me enlarge it. 4.37, this one. I'm taking the last value because after 1 I don't have any other factor. So in that case, you can take the last value. If I had, for example, for 0.9, then I can do interpolation. If you have both values, you can do interpolation. If you're on the extreme side, you just take the last number, okay. Is this clear? Okay, moving on. If the adjustment factor for heavy vehicles on extended freeway segment with level terrain is 0.9556, what is the percentage of trucks and buses we have? Okay, so the adjustment factor is given, means FHV is given, okay. FHV is given, and I believe there's something missing. FHV is there, and you have to find out the percentage PHV. You need the EHV as well. So the terrain is missing here. Okay, the terrain is missing here. Okay, the terrain can be level or rolling, so then I can use it. If it is general extended level terrain, sorry, okay, it's given level terrain. Okay, so FHV is which one, Mariam? Which one are you saying to explain more? Okay, for we have the EHV factor. Okay, EHV factor, if you have extended gradient, then you have to select from one of these three tables, this one, or this one. The difference between these three tables is the distribution of single unit trucks and trailer trucks. Okay, if single unit trucks are more, you will use this one. If both of them are equal, you will use this one, and if one of them trailer trucks are more, you will use this one. Okay, what I was trying to explain is the 30 and 70 is not for the total traffic. 30 and 70 is from the percentage of heavy vehicles. So from the total traffic, I had 6% trucks. From those 6%, 30% are single unit, 70% are trailer. Okay, then you will use this table. If from the 6% both of them are equal, you will use this table. If from the 6%, 70% are single unit, 30% are trailer, then you will use this table. Okay, so this percentage which you see on the side is from the heavy vehicles themselves, not from the total traffic. Okay, and the percentage which you see on the top of the table, these values are from the total traffic for the heavy vehicles. Okay, and then you look at the percentage of grade. When you look at the length, and you will find the EHV factor. And another point which I mentioned, that for example that this part ends at 1.5, but your length is 2 miles. Okay, so if you go out of this limit, then you will take the last number from the table. Okay, so whether my length is 2 miles or 3 miles or 5 miles, I will take the number which is for the last length, which is 1.5 miles. Okay, is it clear now? Okay, so FHV, okay, is given 0.956. FHV equals to 1 divided by 1 plus PHV EHV minus 1. Okay, so I need PHV and EHV here. PHV I need to find. Okay, EHV I will take for level terrain, because it is given level terrain. Where is it? Okay, for level terrain EHV is 2. Okay, so I will take this whole thing. Okay, so this equal to 0.956. So how much is my PHV here? Okay, 0.046 means 4.6%. Okay, 4.6%. Moving on. Then we have, yeah, in some cases we may have a combination of gradients. Okay, so if you have a segment in which there is only one value of gradient and one length, then there is no problem. Okay, you will check from this flow chart and you will know your terrain conditions, you will use either this one or one of these tables and you get the EHV. But what if you have multiple gradients? Then which one should I use for deciding my terrain? So we need to combine them. We need to combine different values into a single number so we can do the selection. Now this combination is by taking an average. Okay, if you take simple average, then it will be wrong because some parts of the highway are longer, some parts are shorter. Longer parts have more effect on the driver and shorter parts have less effect on the driver. So we will take the average according to the length. So method of average is called as average gradient method. Average gradient method says that you take the total, they call it the rise or fall. Okay, so I will use the same term, total rise or fall, meaning total difference in elevation upon total length. Okay, total rise or fall in the segment upon total length of the segment. How do we do that? We have this example. We have two gradients here, 3%, 3000 feet length, 5%, 5000 feet length. Okay, so if I calculate average gradient here, it will be, I need total rise or total fall, right? So how much rise is there in 3000 feet? The length into the slope, right? The length into slope will give you that elevation. So same thing for the next one as well. So 5000 divided by total length. Okay, so this is how you calculate the average gradient. What's the value here? Okay, and if you took a simple average of 3 and 5, we have two gradients, right? 3 and 5. If you took simple average, you will get 4. Okay, so this is 4.25%, slightly higher. Why higher? Because 5000 feet has a higher gradient. Okay, so it will be on the higher side. So this average is as per the as per the length. Okay, where the length is higher, the gradient average will go towards that side. And then you have some other examples here. Okay, you can try it, it will be in the same manner. Okay, so if there are 3 gradients, you will add 3 terms in the ratio and so on and so forth. If there is a negative gradient, meaning downward, you will put a negative with it. Okay, so positive means rise, negative means fall. Okay, and you will take into account when you will put the sign. So negative, if you have a negative here, like here, if let's say 3 was negative, 3% was negative, I'll put a minus sign here. Okay, so it will be minus 3000 into this and so on and so forth. But length obviously will not be negative. Length will remain as it is. Okay, so now we have done all the factors. Okay, free flow speed, FHV, adjustment factor, blah blah blah. Now we are moving on to the analysis now. This is a old freeway, urban area. It has 4 lanes, 10 feet lane width. It has lateral obstruction after 0 feet, meaning no clearance. After the road 0 feet, I have an obstruction. That means no lateral clearance. Ramp density is given. We have rolling terrain. Trucks are 2% of the traffic. Okay, so terrain is rolling and trucks are 2%. Peak hour factor 0.95. The volume in the peak direction is 3000 vehicles per hour. In the peak, what do you call it? In the peak hour. Okay, and they are asking us to find out the level of service. Okay, they are asking us to find out the level of service. Now, what type of analysis are we doing here? Is it operational, service flow rate, or what was the third one, design? In this question they're asking for level of service, so which analysis is this? Yeah, what about the other 10 people? Which analysis is this? Yeah, the other 6 people. Okay, yes, it is operational analysis. Now let us move on. Whenever you have something like this, you need to start by free flow speed. The first thing we should know is the free flow speed. Okay, for the free flow speed, we already used an equation earlier, 75.4, it was a constant. Then you need the factor for lane width, lateral clearance, and ram density. Okay, lane width 10 feet, lateral clearance 0 feet. Factor for lane width, 10 feet lane width, factor is 6.6. And I'm using this equation you can see here. I need these 3 factors. Then I need the factor for lateral clearance. I have 4 lane freeway, meaning 2 lanes in each direction, and 0 feet clearance. So the factor is 3.6. Then we have the ram density. Okay, ram density is 5 frames per mile. How much is the free flow speed? Okay, so this is my free flow speed. Moving on, the next thing I need is a flow rate. Okay, but to calculate the formula, very good, very precise. To calculate the flow rate, I need the FHV factor. Okay, now it is rolling terrain. I need the percentage of trucks, which is 2%, and then I need the so it's rolling terrain. I showed you the table. Okay, rolling terrain, the factor is 3. So how much is the FHV factor? Okay, then you can find out VP, flow rate. So I will use the volume. Volume is, where is the volume? 3000. Okay, number of lanes for one side, remember. So 2 lanes. Peak hour factor 0.95. Factor for heavy vehicles 0.96. Okay, what's the flow rate? Sorry, it's 0.96, okay, not 0.06. 0.96. Yeah, how much is that? Okay, I got the flow rate. Now I want to calculate density. Density is V upon S. Okay, VP upon S. You already have VP, but I don't have speed here. Okay, for speed, I will go back. to my speed flow curve. Okay, now S can be equal to free flow speed, which I already have, or S can be equal to this whole thing. Depends upon where is my breakpoint. It depends upon where is my breakpoint. Okay, so I need to compare VP with my breakpoint. This is my breakpoint. Okay, so we calculate breakpoint here. Your speed was 52. There are no adjustments here, okay? No conditions for adjustments are given. So how much is my breakpoint? Okay, so VP is less than breakpoint. That means speed equals to free flow speed. Okay, so how much is my density then? Okay, if this is my density, then my level of service was, where was it? Yeah, this one. Okay, your density is 31 point something. 31 is here for the freeway. So my level of service is D. Okay, any questions? Okay, now one thing here which you can notice, that my speed equals to free flow speed. Free flow speed is the best thing you can have. Okay, so but still the level of service is D, which is very low. So speed is very high, the free flow speed is very high, but the level of service is only D. Okay, why is that? This is because of the conditions of the highway. So even without traffic, I can only go as much as 52.8. Okay, this is because of the conditions of the highway. What conditions of the highway? Let me go back to the question. Okay, so you see lane width 10 feet is very low. Okay, you may not find it even on a local street in Bahrain. Okay, so 10 feet is very low for a freeway. And then you have zero lateral clearance, and you have many ramps per mile. 5 ramps per mile is very high. Okay, this means like after every few hundred meters you have a ramp. Okay, so because of the highway conditions, even without traffic, people cannot go at good level of service. Okay, so this can happen as well. Then in the same example, with the same data, what if we have bad weather conditions, meaning we have moderate rain? Now the factor for rain can affect speed and capacity both. It has a speed adjustment factor as well as capacity adjustment factor. Okay, so moderate or medium rain, first of all let us look at its factors. So this is for capacity adjustment, CAF. Medium rain, now you can see my free flow speed is 52 point something, but here I have 55. So as I told you, when you go to the extreme, you cannot do any interpolation because there is no next value. So you just take the last number. I'll take 0.94 here. So capacity adjustment factor 0.94. Then I have speed adjustment factor for the weather condition. Same rule, 52.8. Interpolation not possible. I will just take the last value, 0.96. Okay. That means free flow speed must be adjusted. Okay, so free flow speed was 52.8 multiplied with the adjustment factor. So how much is that? Okay, so this is your final free flow speed now. This is the one which you will use. Okay. In the previous calculations, I already calculated flow rate. Flow rate equation has no issue with rain. So it will remain as it is. Okay. But the breakpoint can change. Remember, I was comparing flow rate with breakpoint to find out the speed. So the breakpoint can change because I have changed the speed. So breakpoint must be recalculated. And it was multiplied, let me check. Okay, so whole thing is multiplied by the capacity adjustment factor. Capacity adjustment factor 0.94. Okay, so how much is this? Okay, so my flow rate was 1645 and now it is higher than the breakpoint. Okay, that means the speed must be recalculated using this equation. No, sorry. It is still lower. Okay, so speed still free flow speed, but not the speed which I used earlier, adjusted free flow speed. Okay, so I will recalculate the density with the adjusted free flow speed. How much is that? Okay, so looking back at the level of service, 32 is still here, level of service is D. So what did actually change because of the weather conditions? First thing is free flow speed changed. It is reduced. Okay, it makes sense because when you have rain, you will try to go slowly. So free flow speed has changed. So free flow speed means what? You are reducing your speed even without or not because of traffic, because free flow speed means there is no traffic. Okay, this reduction in free flow speed, did it change the level of service? No, it did not change the level of service, but it increased the density. More density means less spacing. Okay, so people are going slowly and they are very close to each other. When they go slowly, they are closer to each other. The spacing became less, but the overall level of service still D, no change. Okay, understood? Any questions? Okay. Okay, the next example is for a multi-lane highway. It's 4 lane, it's a median. Its peak hour volume 2600. Again in one direction. It has 12 feet lane width, 4 feet clearance on both sides. Road side means right hand side, median side means left hand side. So it has clearance, same clearance on both sides. Maybe it's a shoulder. 10 access points per mile, 10% trucks, standard mix. Okay, standard mix means standard mix is more single unit trucks and less trailer trucks. Okay, this is called a standard mix. Standard mix, more single unit, less trailer trucks. Okay, the segment has a gradient now, and the gradient length and value is given. Base free flow speed is given. They are asking for level of service on the upward grade and the downward grade. Okay, now you can see the volume is for one direction. So assume this volume in the upward direction for one case, then in the downward direction same volume for the other case. Okay, so this is called as the journey effect. When you go in one direction, if how many people are there, if 2600 people go in the morning in one direction, they'll come back in the evening from the other direction. So if they went up in the morning, they will come down in the evening. So you can consider same volume for different time settings. Okay, so again the first thing we need to look for is free flow speed. Okay, free flow speed for Multilane highway, we have another equation. So free flow speed, I need the base value first, base value 65. If we need the factor for lane width, letter clearance, and median and access points. Okay, so lane width 12, letter clearance I need for both sides. Okay, let me write these values here. Lane width 12, letter clearance total, so 4 plus 4. It's not always equal, right? In this question they are saying it's equal, so I'm taking 4 plus 4. 10 access points per mile. Okay, so now let us, and it has a median. So if I go to the free flow speed, okay, factor for lane width is 12, factor is 0. Factor for letter clearance, 4 lane freeway, letter clearance 8 feet, factor is 0.9. It has a median, factor is 0. Access points 10, factor is 2.5. Okay, how much is this? Okay, so this is my free flow speed. Next thing is my flow rate. For flow rate, I need FHV first. Okay, I have 10% trucks. Then I need to find out the EHV. EHV, I have a terrain here, 3.5% grade, 1.25 miles length, and I have to consider up and down both. So I will have two factors here, one for upward, one for downward. Okay, if I look into this chart, 3.5% length more than, sorry, gradient more than 3%, length more than 0.25 miles. So I have extended gradient. Okay, they have a standard mix. Standard mix I told you is this one, 70%, 30%. 70% single unit, 30% trailer. So this is standard mix. Okay, so I will look somewhere here. 3.5% gradient, 1.25 miles length, and 10% trucks. 3.5 gradient, 1.25 mile length, and 10% trucks. My factor is 2.96. This is upward. This is for upward. For downward, you will go on the negative side. Do I have anything after this? No. So I'll just take the last value for this combination for minus 2%. Okay, so 1.25 miles, 8 and 10% trucks, 1.96. Okay, so anything after 2% will have the same value. So 1.96. So upward is where was it? Upward is 2.96, downward is 1.96. Okay, so let's say I'm doing it for up. I'll use 2.96 here, and for downward just replace this with 1. Yes, what are these values? Okay, so the next thing is we calculate the flow rate. Okay, so flow rate, because FHV is different, flow rate will be different, one for up, one for down. Okay, okay, so the volumes 2600, 2 lanes, peak hour factor. For up I will use 0.83. For down I'll have the same thing. Okay, so which one is what? 1779 is what, down? Hmm? 1779 is down, is up. Okay, so now the next thing is we need to compare it with the breakpoint. It's a multi-lane highway. For multi-lane highway, breakpoint is 1400. It's fixed, there is no equation. Okay, and it is less than my VPs for both conditions. Okay, so that means what? I cannot take free flow speed as S. I have to use this equation. Okay, this big equation, and because VP is different for up and down, that means S will be different for up and down as well. And this equation I have capacity as well, so I need to calculate capacity. Capacity has this equation, so C equals free flow speed was 61.6 45. So this will give me the capacity. After I calculate the capacity, I calculate S for up, free flow speed, capacity. DC is 45. I told you earlier as well, DC is 45, it remains 45. This is according to the highway capacity manual. VP, I am doing it for up, so 1780, I'm rounding off, minus BP, which is 1400, to the power A. A is for multi and highways, the A is 1.31. Okay, it's given in the table, don't worry. Then capacity minus BP power 1.31. This is for up. For down, I will change the flow rate. One 623. Okay, anything else changes? No. Okay, so, and this will be for down, sorry. Okay, so how much are these values? Okay, and the down, you just change the value for VP there, for the down. Okay, so now we can calculate density. So again, for up 1780 divided by 57.3, for down 1623 divided by 59.5. Okay, what about these values? Okay, so 27 and 31, if I go here, 27 and 31 both are level of service D. So the terrain condition both in the morning and evening, they maintain the same level of service. Overall traffic conditions in the upward and downward terrain remains the same. Any questions?